Okay, so what we're going to be doing now is talking about grade resistance. It's one of our first, I guess, real-life examples or applications of some of the trig that we're basically learning. So let me go ahead and set the stage up. It's I don't know if my language will match some of your physics professor's stuff, but I'll try really hard. So here's the situation. What we have basically is a situation where we have a hill. And this hill has a angle of elevation, right? So we'll call that theta. And then there's, let's say, a little truck or a little block or whatever the case might be. Sorry, my drawings aren't the best, okay? And so we have a little car sitting on the hill, all right? And there's basically a force, right, of gravity, which is basically the weight of the car. Right, so this car weighs, a certain amount of pounds, and so that force basically acts straight down, right? That would be the force. How about I call that Fg, right? That's the force due to gravity in this situation. But it turns out that that force due to gravity is actually broken up into two other forces. There's a force normal, and then there's a force what we call of friction. Okay, and the force normal, let me change colors here. The force normal, well, normal means perpendicular. So this basically will behave, right, going in this direction right here. So that is our force normal. So it's the force going directly into the hill, if you would. So how much of this weight of this car is going directly into the hill itself. And then, of course, what we have, the force of friction. If I'm sitting on a hill, of course, this force is going to force me down the hill. So that force here, right, let me redraw it here to complete. You'll notice I drew a right triangle. But this force that I have, let me put it in another color. Let me put it in black. That is basically your force due to friction. Okay, and it's that force due to friction that we call, or what the book is calling, the grade resistance. And I'm pretty sure your physics professor will have another thing. I actually think it's called mu or something of that nature, if my memory serves us right. But that's what we're going to be looking at here. So there's actually three forces. The force due to gravity, right, which is essentially our weight, and then the force normal, and then the force of the resistance, which is the inclination of the object to move down the block. Or if I had a little block here, right, it's the force the block would do to keep that that object, in this case a car, sitting there and not sliding down the hill. And so how do we find that force of grade resistance? Well, if we use the concept of transversals and all that other good stuff, which I'm not going to get in here and bog the memory, but it turns out that this angle of elevation is this angle in this little right triangle that I drew. And you can see for this right triangle that I have, the force that we're interested in serves as the opposite, and the weight of the object serves as the hypotenuse. And so it turns out, if we set this up, that the sine of that angle, and again, that's the angle of elevation, right, we know to be equal to the opposite over the hypotenuse. But in this case, the sine of theta is equal to the grade resistance, let me call it F of F, divided by the weight of the object itself. And so if we multiply both sides by W, what we end up having, and let me go ahead and just call this the grade resistance, we basically have a grade resistant formula, right? The grade resistance is equal to the weight of the object times the sine of theta, right, where W is the weight of the object, right, and theta is the angle of the incline, or of your hill. And so it's a pretty handy-dandy formula. We'll basically use it here in the next set of videos. So there is your formula. So the grade resistance, call it G, call it F. I think the book does actually call it capital F. is W sine theta. All right. If you wanted to be official, put a little g down there. So the grade resistance, the force of grade resistance, the force of friction, as your physics professor will be, is the weight of the object times the sine of the angle of elevation. There's our formula. There's the setup. There's the build-up. Now let's go do some problems where we use it. All right, and I'm going to do that in another video coming up shortly.